Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on the chapter rotational motion. We are solving the problems on law of conservation of angular momentum. This is part 12 of the video. Kindly see the previous videos also so that you can understand all the problems on rotational motion chapter. Now this is the first problem. This problem is same as the previous video, but I have changed the data. Okay, now this is the first problem. The ball of mass 0.1 kg rotates in a horizontal circle of radius 1 meter at a constant speed of 1 meter per second on a frictionless table as shown in the figure. Okay, the ball is attached to a string which passes through a hole in the table. By pulling the string at the lower end, the radius of the path is reduced to 0.5 meter. Now they have given four options. One we have to tick. Now I will write the top view of this one. Okay, this is a circle. Okay, if you see from the top, you will get a circle. This is the radius. This is a ball of mass. M is equal to how much? 0.1 kg. Okay, this is V1 is its speed, that is equal to 1 meter per second, and radius is how much? R1 is equal to 1 meter. There will be a tension in the string T1. Now, by pulling the string at the lower end, the radius of the path is reduced to, now this is reduced to 0.5. Okay. If you pull, the ball is attached to a string which passes through a hole in the table. By pulling the string at the lower end here, okay, the radius of the path is reduced to how much? R2 is equal to 0.5 meter, 0.5 m. This is tension will be there, T2, and now V2 you have to calculate, V2, and T2 you have to calculate. Okay, final tension and new velocity. Now this is tension T2. Now if you observe the tension here, since tension is radial, okay, this is radial. Since tension is radial, torque will be equal to how much? 0. Okay, since tension is radial, okay, see what is the angle between this R radius and this force, that is 0 or 180 degree. Whenever it is 0 degree or 180 degree, what will be torque? Torque will be equal to 0, because we know that tau is equal to RF sin theta. If theta is 0 degree or 180 degree, tau will be equal to 0, where theta is the angle between R and F. Understood? That is force. That is tension. Now we know that when torque is 0, therefore angular momentum is conserved. That is mvr is equal to constant, and again here mass will be 0.1 kg. Okay, mass is also constant. The product of Vr is also constant here. Okay, since mass is constant, I can remove this one. The product of Vr is constant. Now I can write V1 R1 is equal to V2 R2 here. Now calculate V2, because we know the other parameters V1 R1 by R2. How much is V1 given? 1. R1 is how much? 1. Divided by R2 is how much? R2 is 0.5. That is 1 divided by 1 by 2 means V2 is equal to 2 meters per second. Now if the radius is shrink to 0.5 meter from 1 meter, the speed, the velocity increases. V2 is equal to 2 meter per second. Okay, 2 meters per second. Here this is new velocity of the ball is 0.5. Now this is also. Now you have to calculate the tension. Now let us calculate the tension. Now it is the tension is what? Centripetal force. T1 is equal to what? M V square P1 square by R1. Okay, that is equal to M is how much? 0.1. V1 how much is given? V1 is given as 1 the whole square divided by R1 is how much? That is equal to 0.1. That is equal to 0.1 Newton. Okay, that is T1. We have to calculate T2. Okay, T2 is equal to what? M V2 square by R2. How much is M? 0.1. How much V2 we got? 2 the whole square divided by R2 is how much? That is 1 by 2 I can write. That is equal to 0.1 into 4 into 2. That is equal to 0.8 Newton. 0.8 Newton. Yes. The final tension in the string is 0.8 Newton. This is the correct answer. Final tension in the string is how much? 0.8 Newton. Hope you understood. Okay. This is the same problem what we did in the last video, but here I have changed the values. You have to understand this kind of problems. This may be asked in your examinations. Now we will go to the next problem. What is saying? A cubical block of side A, okay, side A is moving with velocity v, okay, on a horizontal smooth plane as shown. It hits a ridge at point O. Okay, there is a ridge here. Okay, the angular speed of the block after it hits O is how much? Now here net torque about O is 0. Therefore, angular momentum is about angular momentum about O angular momentum about O will be conserved. Because there are no external forces. Okay, net torque about O is 0. Therefore, angular momentum, that is L, okay, about O will be conserved. That is L is conserved. That is mvr is equal to constant r I into omega is constant, right? Now here it is what? Tm, translatory motion. Okay, now Li is equal to Lm. Now how to write Li for a translatory motion? Okay, this is mass m, okay, which is moving with a velocity v. Okay, how to write mv? What is L is equal to mvr? Then r is how much? This is the line of action. Okay, if I extend this one, what is the r value? R is this one. This. Okay, L is equal to how much? R is equal to this side is how much? A. Right. This will be exactly R is equal to A by 2. Li is equal to what is the mass of this cubical block? That is m into v is equal to I into omega. What happens now? After some time, the block moves here, okay, and it hits the what? It hits the ridge. It hits the ridge at point O. Then it topples. Okay, it topples. The angle omega they are asking here. The angular speed of the block after it hits O. Okay. Now how to calculate I here? I at point O you have to calculate. I at point O you have to calculate. How to calculate I at point O? If I substitute, I will get the correct answer, value for omega. How much is for a, we know that for a square lamina, of side A and let us say mass M, okay? Square lamina. I'm talking about what? Square lamina. Side A, square lamina of mass M, let us say M is there, okay? What is, if this is the center of mass of the square lamina, this is the centroidal axis. What is ICOM here? ICOM is equal to 1 by 6 MA square. 1 by 6 MA square. This you have to remember. Now if I have to calculate at the corner somewhere here, what I have to use? I have to use parallel axis theorem. Same thing is happening here. Okay, this is ICOM. Okay. This you have to calculate what? This is IO. IO is equal to what? ICOM plus mass of this one and h square. And what is h? H is the distance from point C to point O. Right? How much this will be? The value of that one is how much? A by root. What is the, in a square, we know that in a square, this side is A. What is diagonal? Diagonal is root 2A, right? Half of that one is how much? Half of that one will be how much? That is A by root 2. A by root 2. That is same here. H, that is R is given here. Okay, R is given. R is equal to what? That is equal to H. That is equal to how much? A by root 2. A by root 2. Hope you have understood. Okay, ICOM is how much? 1 by 6. What is the mass of this cubical block? 1 by 6 M A square plus of M into, what is that H? H is equal to A by root 2 the whole square. A by root 2 the whole square. Hope you understood. Okay. Now I0 is equal to 1 by 6 M A square plus of M A square by 2. Right. That is equal to, I can take M A square as common, 1 by 6 plus 1 by 2, that is equal to M A square. I can take 6 as LCM, 1 plus of 3. I naught is equal to, that is I0 is equal to M A square 4 by 6 M A square 2 by 3. I can write 2 by 3. Now substitute this one here. Okay, MV A by 2. I'm just substituting here. I naught is how much? 2 by 3 M A square omega. Okay, you can cancel. M and M gets cancelled. A and power 1 gets cancelled. Okay, omega will be equal to how much? Omega will be equal to 3V omega is equal to 3V 2 into 2, 4, and A is remaining here. Okay, omega is equal to 3V by 4A is the right answer. Omega is equal to 3V by 4A is the right answer. Hope you understood this. This is a very important problem based on what? Law of conservation of angular momentum. Okay, this I naught is very, very important. How? Okay, that is 1 by 6. Understood? Because if I have to calculate here, that is I 0, what are we doing? I com plus I'll be writing m h square in the same way. Now let us go to the next problem. Read this problem. Again, this problem is based on what? Law of conservation of angular momentum. A smooth uniform rod of length L and mass m has two identical beads. Beads are there here, okay, of negligible size, each of mass m, which can slide freely along the rod. Initially, the two beads are at the center. They are at the center here. Okay, two beads are there at the center here. This is one bead. This is so its contribution for moment of inertia is 0. Okay, mass m. Initially, the two beads are at the center of the rod, and the system is rotating with angular velocity omega naught. Okay, about an axis perpendicular to the rod. Okay, and passing through the midpoint of the rod. See figure. Okay. There are no external forces. Therefore, since no external forces, and moreover, if you rotate this one, okay, this will be moving radially outwards. Okay, since motion, right? Since motion is radial, okay, we know that at the time torque will be 0, L is conserved. L is conserved. That is okay. I omega is constant. Therefore, I can write I1 omega 1, that is Li is equal to Lf I1 omega 1 is equal to I2 omega 2. What is I1? I1 is, this is rod of mass m and length L. What will be I1 at the center? I com for rod is how much? That is equal to 1 by 12 ml square. Okay, I1 is 1 by 12 ml square. Okay, centroidal axis. Okay, for a rod of length L and mass m. Okay, mass m, length L. Okay, if I draw a centroidal axis, its I com is 1 by 12 into omega naught is given. Okay, omega naught. Omega 1 is how much? Omega naught. Now that is equal to I2. Now when the beads come at the end, okay, finally when the beads comes here, okay, this is m, this is m, this is initial, this is what? Final beads of mass m comes to the corner here. What happens? I2 is nothing but at that time moment of inertia of this rod, that is 1 by 12 ml square plus of moment of inertia due to this point masses. Okay, what is the formula for point mass moment of inertia? I is equal to m r square. M, okay, r is how much distance? L by 2 the whole square. Like this, how many masses are there? 2. Okay, 2 point masses. 2 into m into L by 2 the whole square. Hope you understood. Right. Next, you are supposed to calculate what? Into omega naught. That is final. Okay, that is omega final. You have to calculate. Now, you need to just simplify this. 1 by 12 ml square omega naught is equal to 1 by 12 ml square plus of 2m L square by 4. Understood? Into omega m. Hope you have understood this one. Next is 1 by 12 m L square omega naught. I can take L square as what? Common here. L square as common. I can take m by 12 plus of m by 2 I can write. L square gets cancelled. 1 by 12 omega naught is equal to, now here I can take 12 as LCM, m plus of 6m, 12 gets cancelled. Omega f is equal to omega naught, m is remaining here, okay, m will be there here, m omega naught divided by m plus of 6m, m plus of 6, okay, L square, okay, 12 gets cancelled, m is here, this is the final answer. Omega f is equal to m omega naught divided by m plus 6m. Where is the answer? M omega naught divided by m plus 6m. This is the C is the right answer. Students, hope you understood. These are the problems which are not complicated. Okay, little bit lengthy. These are the level 2 problems. You have to concentrate. Try to see 2 times or 3 times. You will understand. Okay, I will stop it here. Kindly subscribe for my channel to see interesting problems like this. I wish you all the best for your KCET, NEET and IIT JEE final examinations and test in between. Okay, whenever you have test, prepare well for the test so that you can do well in the final examinations. Kindly subscribe for my channel, ask doubts in the comment box, share this video with your friends, like the video. Thanks for watching my video.